Yes, children. Good morning. We saw the reaction of glucose with HI. Then we saw it with hydroxylamine, right? And then with hydrogen cyanide, and then with bromine water, and then with acetic anhydride, right? And then with concentrated HNO3. Okay, so all these things, it gave us an idea about an aldehyde group in glucose. Then there are 5 OH groups, and all the carbon atoms are in a straight chain. Okay, so these are the basic fundamental things that we could derive from these reactions, and we described the structure of glucose, is it not? So it should be having on the top a CHO group, and then you have CHOH 4 times, that is CHO, CHOH 4 times, and then a primary alcoholic group at the end. So this is what we discussed, okay, from all these reactions. Okay, now what is the problem? The problem is this structure of glucose, it explained most of the properties, but not all. It could not explain all the properties. Why so? In spite of the presence of CHO group. CHO group is there, we decided, is it not? But then it is not giving the 2,4-DNP test, 2,4-dinitrophenylhydrazine के साथ reaction होती है ना, वो होता नहीं है. Then it is not giving Schiff's test, which is a typical test for aldehydes, and it does not form bisulfite addition product also. It is forming cyanohydrin, but it is not forming sodium bisulfite. Okay, if carbonyl group is there, then it should give all the properties which are corresponding to that carbonyl group, is it not? But it is not giving. So they were wondering why so. And also the pentaacetate of glucose does not react with hydroxylamine, showing that there is no free aldehyde group. Pentaacetate, see, we said there are 5 hydroxyl groups, 1, 2, 3, 4, 5, is it not? 5 hydroxyl groups है तो ये तो free होना चाहिए, ठीक है? अगर ये free है, then this should be reacting with hydroxylamine, and the pentaacetate is not showing any reaction with hydroxylamine, which shows that there is no aldehyde group at all. There is no CHO group. It is not free. Okay, and also this glucose was found to exist in 2 crystalline forms, alpha and beta. The alpha form is having a melting point of 419 Kelvin, and it is obtained by crystallization from concentrated glucose solution at 303 Kelvin. And the beta form is obtained by crystallization from hot and saturated aqueous solution at 371 Kelvin. One at 303 Kelvin and the other one at 371 Kelvin. So 2 forms of glucose have been obtained. Okay. Now, what is this alpha and beta form? What makes it alpha? What makes it beta? And the existence of this alpha and beta forms could not be explained by open structure. तो अगर ये देखोगे तो इसमें से अल्फा फॉर्म क्या होगा, बीटा फॉर्म क्या होगा, कुछ पता नहीं चला. ओके, देन व्हाट वाज कंक्लूडेड that glucose, it forms a hemiacetal structure which is cyclic in nature, in which the free aldehyde group is not there. Okay, now we have seen what is meant by hemiacetal when we saw aldehydes and ketones chapter. What was that? See, this is the carbonyl group, right? And this carbonyl group, it is reacting with ROH, and ROH splits in the form of RO minus and H plus. And this carbonyl group, there is polarity, bond pair is shifting towards oxygen, making carbon positively charged, and this positively charged carbon is attracting OR minus from here, and this OR is attached to carbon, is it not? This is called as the hemiacetal formation. Now, in the case of glucose, what is this hemiacetal formation? See, there is a CO group, and there is a OH group. Now here you had aldehyde in one molecule and ROH is another molecule. There are two different entities, is it not? But here, fortunately, in the same molecule, you are having both aldehyde group as well as alcoholic group. Okay. So there is internal shifting of one group towards the other. How it is taking place? See, now at the fifth carbon, this OH bond is breaking and this hydrogen is going and attaching itself to the carbonyl oxygen, and when this is becoming OH, now this makes carbon positively charged, and this positively charged carbon is now attaching itself to O minus of this OH group. Okay, so this is what you will get. This carbon is now attached through oxygen to the fifth carbon. Okay, now you may ask, why can't this shift take place with this OH itself, or with this OH, or with this OH? Why with only the fifth carbon? If it had happened here, then there was such a lot of steric hindrance. Same way with this also, with this also. So जितना दूर होगा उतना ही steric hindrance कम है, and the resulting structure is more stable. Now this is going to give you hexagon, is it not? Now you see 1, 2, 3, 4, 5, 6. Okay, so there is a ring of 6 members, right? Now a 6-membered ring will give rise to a hexagonal form, and that has been found to be much more stable. That is why this cyclic structure is formed between C1 and C5 through oxygen. Okay, so together it becomes a 6-membered ring, and this is the hemiacetal form of glucose. Okay, C1 and C5, it is linked through oxygen. Okay, now from this, how they decided or how they came to know about alpha and beta form, you see. Now this is your open chain structure, right? CH2OH, CHOH, and then CHO at the top. Okay, now this carbon and this oxygen, it is being linked. Okay, when it is linking, then what is happening? This CO is becoming COH. Okay, now the position of OH, if it is to the right, then it is called as alpha form, and if the position of OH is to the left of the first carbon, the carbonyl carbon, then it is called as beta form. Okay, so this is what is called as alpha D-glucose, and this is called as beta D-glucose, and in between they have shown this open chain form. Okay, so this is how they came to understand that glucose is existing in a cyclic structure, right? Now in this cyclic structure, there is no free aldehyde group, so it is very obvious that it may not be giving sodium bisulfite reaction. It may not be reacting with, it may not be having pentaacetate in which there is no free aldehyde group. Now you see 1, 2, 3, 4, 5. There are 5 hydroxyl groups and pentaacetate is formed, right? So there is no necessity for aldehyde group. So this is how they came to understand the structure of glucose, that it is not existing in the open chain form. Hardly 0.2% this will exist in a mixture, but most of the time you will find glucose existing in this hemiacetal form or the cyclic form, right? Now the two cyclic hemiacetal forms of glucose, where do they differ? They differ only in the configuration of